Welcome back to Physical Anthropology. Today we're looking at Chapter 15, Bioarchaeology and Forensic Anthropology. We'll start by defining what is forensic anthropology, and then we'll look at specific skeletal traits that are used to determine biological profile, including the sex, age, stature, ancestry of that individual, as well as skeletal variation, trauma, and pathology. So what's the difference between bioarchaeology and forensic anthropology? Both of them are going to study human remains. The main difference is that bioarchaeology is looking at more distant humans and trying to learn more about those cultures and populations based on the skeleton as well as any other material found, such as grave goods, and they're trying to put it in an archaeological context to try to find out more about the lifestyle of those people. In comparison, forensic anthropologists tend to look at more recently deceased individuals, and they may be used to solve crimes. So if the body has decayed enough that the soft tissue is no longer useful for identifying the person, we can use skeletal features instead. And this can be used to help solve missing person cases, as well as determining the cause of death of that individual. So both of them do focus on skeletons. It's just a question of how old is that skeleton? Is it relatively recent, for example, the last couple decades, or is it more like hundreds or thousands of years old? So what kinds of questions will forensic anthropologists ask? First, they're going to try to determine if the object is in fact a bone and if it does in fact belong to a human. Then they'll determine if it's a relatively recently deceased person or if it's an older, more archaeological site. They'll try to determine the number of individuals at the site because sometimes you have multiple people buried in the same location and an intermingling of bones. And finally, we're going to try to figure out who is this person, what are their identifying features, and what kind of trauma or cause of death might there be. So what's going on with damage to the skeleton? So for initial skeletal analysis, we first want to determine that it is in fact bone. Sometimes, especially with fragments, they might look like bone superficially because they're white and porous, but more detailed investigation shows that it is not in fact bone. Another interesting question is, does it belong to a human? The skull would be a very easy way to determine that it's human, but sometimes you don't find the skull, you only find other bones, and things like ribs might be very similar to other animals. Vertebrae can be used to help determine if the animal is bipedal, which would indicate a more likely chance of it being human. And then you can also look at other skeletal features. So the image on the top right is just showing you how similar a human hand and a bear hand actually are. Superficially, they both have the 5 fingers and the shapes of the bones are relatively similar, but you can see that there are a couple of differences, such as the deep V-shaped groove in the bear versus the human. If you do happen to have multiple individuals at a burial site or at an archaeological site, you're going to try to determine the minimum number of individuals or the most likely number of individuals. And this will be determined by the type of bones you find. So for example, if you find 5 skulls, then you know that there were at least 5 people there. However, if you find 10 ribs, what does that mean? Are all 10 ribs from the same individual or were they from different individuals? So different types of bones will help you try to figure out what's the absolute least number of people that are there, and there could potentially have been more. Finally, to determine if it's a modern or archaeological site, you might look for certain things that are only found in modern people, such as dental fillings, metal dental fillings, or things like joint replacement. But you can also use radioactive carbon dating, and then that will help you determine the age range that it belongs to. So next, we're going to start constructing a biological profile of this individual. And one of the first questions we might ask is the individual male or female? So to determine biological sex, the most common bones we would use are the pelvis and the skull. And that's because the rest of the bones are fairly similar in both males and females, but pelvis definitely has some distinction in adult males and females, as does the skull. So there is going to be some sexual dimorphism in humans in terms of things like stature and in terms of the robustness of the skull. So in this image on the right, you can see the comparison between male and female skulls, and you can see that in general, males are going to have a thicker, more angular jaw, while a female might have a more pointy jaw. You're going to see thicker cranial bones. You're going to see larger, bumpier projections like the mastoid process right there, while with the female, it's going to be smaller. She's going to have a more smooth looking skull. However, there's certainly possibility of overlap there. The age of the individual will influence this. For example, if it's a teenager, you might not have such a distinction. If it's a small child, you basically can't tell the difference between males and females. So it would have to be a mature individual. Also, do take into account is a subject and is a question of whether that person identified as male and female in their lifetime, but that's not what we're looking at here. We're looking at the biological sex. So when looking at the pelvis, there's definitely differences in male and female pelvis. This is due to the estrogen production that happens in females at puberty. And what that does is it widens the pelvic cavity to allow that female to be able to give childbirth when she's pregnant. So if you take a look at some of the differences here, there's something called the pelvic brim. That's basically how wide the opening is between the sacrum and the two os coxa, which are your two pelvic bones. You're going to see that in the male, it's more likely that the sacrum will have the coccyx, that's the tailbone. The coccyx will curve inwards, while with the female, it's less likely to curve inwards. If it does curve inwards, she's more likely to break her tailbone during childbirth, which is not a pleasant experience. Another thing that we might look at is the subpubic angle. In the male, it's going to be a narrower angle, while in the female, it's a much broader angle. You also see something called the narrowing of the medial aspect of the ischiopubic ramus. That's right here. So how thick is this bone? If it's relatively thin, it's more likely to be female. If it's relatively thick, it's more likely to be male. The images on the right are showing you two different pelvises with a fetal skull placed in between. So you can see this is a female pelvis because the angle is large enough to allow this fetal skull through. And the fetal skull, interestingly, is not fused. So there's a lot of cartilage and fibrous tissue in between the skull plates. This allows the baby's head to be squeezed during childbirth. And sometimes you do have babies that are born with kind of a bell-shaped head. It will round out later naturally, but this is to give them the ability to squeeze through a very narrow space. In comparison, this male pelvis on the bottom, you can see that the fetus would be trapped. There's no way that that skull could fit through this narrow space. Now let's take a look at age. So as I mentioned, if it's a child, we won't know if it's male or female, but we can still figure out their age fairly accurately. And that's because in children, there are certain features visible that are not visible in adult skeletons. So because children are still growing, there's something called the epiphyseal unions. That's basically the growth plates. So if you take a look at this X-ray on the left, we see this crack right here. That means that this bone, this is actually the tibia of the leg, has not completely fused. That means that there's still the ability to grow here. So this would be a child rather than an adult. In the adult, this would just be one complete bone. Another thing we can look at are the teeth. So we know that children lose their baby teeth. The baby teeth are called deciduous teeth, and then we have 32 adult teeth. So if we take a look at the skull on the bottom left, if we count how many of the adult teeth are present versus baby teeth, and you can see actually in the jaw, those adult teeth are still in the jaw, they're developing, they haven't erupted yet. So we can compare that to a dental eruption chart, and we know pretty accurately at what age range those teeth are supposed to erupt. So we can compare that to figure out the age of the child. Now, what if it isn't in fact an adult? Figuring out the exact adult age is a little bit trickier because we can no longer use the teeth or the epiphyseal union. Instead, we might use the pubic symphysis. So the image on the right is showing you the pubic symphysis. If you're not sure what that is, the pubic symphysis is this location right here. So it's where the hip bones join in the front. And the pattern on this portion of the bone can be compared to look and try to determine if the person's a young adult, middle adult, or older adult, but it's going to give a wider range of possible ages. Next, let's figure out the stature of the individual. That's basically how tall they were. We can figure that out using the long bones of the body. And that's because there are certain proportions that we expect to see in a normal human skeleton. So if you measure the length of the femur, tibia, and humerus, you can input that data into a mathematical formula, which will give you a fairly accurate estimation of the height of that individual. So what you can see in this image is a femur. You can see the ruler has been placed there to measure the length. And then what you would do is you would put it into this formula. Now the formula does depend on things like ethnicity because of the fact that different populations do tend to have different male and female heights. So some populations on average are taller than other populations. And what we can do here is find the specific formula for what we estimate this skeleton to belong to. So if it belongs to a European male, we would take the length of their femur, multiply by 2.38, and then add 61.41 to it. This would give us their approximate height in centimeters. It can be used to try to determine if the person is male or female, depending on which range it belongs to, but it may not be that accurate if you don't have the pelvis or the skull, because there's definitely examples of tall women and short men. So we would want to use other features of the skeleton to help determine sex. So what about ethnicity? In a different video, we talked about the idea that human races don't actually exist in terms of a biological standpoint. It's a social construct. However, we can try to figure out some genetic ancestry based on certain physical features of the skull. So the rest of the skeleton is fairly uniform across all human populations, other than something like stature. We all have the ribs and the femurs and the humerus and all of that. So what we can do is look at some skull features that would be associated with certain facial features to help try to determine possible ethnicity. The image in the bottom is showing you the skull, and one of the main things we look at would be the nasal aperture. So that's the opening here of the nasal cavity. Now the soft tissue, of course, is gone, but what we can do is we can measure the width and the height of this opening and get certain ratios that are associated with specific populations. If the person or the individual skull falls between two ranges, then it wouldn't be a very useful piece of data. But if it falls well within the average for a certain ethnic group, then that might give us more information. Also, we wouldn't only look at one data point, we would look at several different ones. So the nasal aperture is just one possible data point. We can look at their dental features. For example, in this skull, you can see there are scooped incisors. That's associated with Asian ancestry. So people of European or African descent do not have the same scooped looking incisor. Some other things you might look at are different bumpy regions on the skull, the eye orbits, the zygomatic arch, which is the cheekbone. And then a combination of these many different factors can potentially give you an estimate of what that person's ancestry is. So my first review question for you, the two parts of the skeleton that are most commonly used for sex estimation are A, the pelvis and skull, B, pelvis and clavicle, C, femur and skull, or D, skull and clavicle. So the correct answer for sex is going to be pelvis and skull. What are some other characteristics that can help us identify very specific individuals? So let's say you are looking for a missing person and the profile of the skeleton tells you that it is a female who is in her 30s and probably of European ancestry. Well, this could still fit a lot of different missing women. So what we could do is look at some information that would be very unique to that individual. If you have dental records, oftentimes when you go to the dentist, they take x-rays of your teeth. That's going to be very unique to you. So if they have a skull of this individual, they could take an x-ray of the teeth and compare it to the existing x-rays of the missing women to determine who it might be. There might be other unique features such as surgical implants. Implants have certain model numbers that are written on them that are unique. So you could compare that to hospital records of missing individuals. Now, what about trauma? Trauma is injury to the skeleton, and it can give lots of different information about that skeleton. It may be injuries that happened during their lifetime. So if it happened during their lifetime, maybe even years before their death, that's called antemortem. And antemortem injuries are going to show evidence of healing because bones can heal over time. We can also see things like stress on bones based on how strongly the muscles are pulling on the bones through their tendons. That can include information about whether the person had to carry heavy loads, whether they had to walk a lot, and so forth. We also have perimortem versus postmortem injuries. Postmortem is going to be something that happened to the bones after death. So for example, someone was moving the body and there was accidentally a fracture to one of the bones. There would be no healing possible after the individual's dead, so we would know it was postmortem. If it's perimortem, meaning very close to the time of death, depending on the level of healing, we could find out maybe the person, broke their leg and the injury was so bad that they were never able to fully heal and they ended up dying soon after. So maybe they died from an infection caused by their broken leg. Okay, so let's take a look at some examples. So sharp force trauma might include linear incisions, such as in the skull on the bottom left, while blunt force trauma would include more crushing types of injuries, like in the picture in the bottom right. Oftentimes we can associate the injuries with certain types of tools, such as whether it was an axe or blunt force, maybe something like a bat. Projectiles leave very specific kinds of marks. So in the bottom left, we see a skull that had a gunshot wound, and there's both an entry point and an exit point in the skull. There can also be evidence of thermal damage. Thermal damage would show that the bones have been burnt. That might have happened either before or after death. Well, it would have happened probably very close to death. They could have died in a fire, or it could be evidence of cremation and someone trying to burn the body after death. So my next review questions for you. What bone feature is used to estimate the age of children? Now there are two possible data points, but which one is specifically on the bone? That's going to be the epiphyseal unions at the long bones. In addition to that, you could potentially use the dental eruption chart. Next, what bone feature is used to estimate the age of adults? So that one is much more difficult because the epiphyseal unions have fused in adults. However, we can look at their pubic symphysis. We're going to wrap it up with bone pathology. Bone pathology is looking at diseases that affect bone development. So this would be diseases that occurred during that person's lifetime. Some of them might be congenital. So it could have been a genetic disorder of the skeleton or something that happened before they were born. It could be traumatic injuries, things like breaking bones. It could be degenerative diseases. So something like a poor diet, which causes osteoporosis or rickets. You can see consequences of certain infectious diseases that affect bone development in negative ways, or metabolic diseases as well. And tumors of the bone. So here are some examples for you. On the left, we have osteosarcoma. That is a type of cancer. And you can see this very unusual shape on this long bone. That is not what it's supposed to look like. You can see there's an extra growth of bone tissue there instead of this nice smooth looking end to the bone. On the right-hand side, we see a genetic condition called osteogenesis imperfecta. This is from an X-ray, and you can see that the bones are bent abnormally due to fractures of the bones. In rickets, we also see bent bones, and these bent bones are found in children because of the fact that when their bones develop, they didn't have enough vitamin D, and so the extra weight has put pressure on their bones, and by the time they're an adult and the bones have fused, they are in this malformed shape. On the right, we see an individual who has achondroplasia. That is a genetic condition where they are not able to transform cartilage into bone properly in the long bones. So you're going to see much shorter height. So this is a fully grown adult, and yet their height and the proportions of their skeleton are unusual. They may have a skull and rib cage that are relatively similar to that of an adult, but in comparison, the length of their legs is going to be much shorter. They will also have additional features on their skull that show abnormal bone growth. And then lastly, taphonomy is studying what happens to the remains after the death. So this could be different types of damage that occurred after the individual was buried, what it can do is it can give us some information about their death. So for example, was the body left exposed in a place where wildlife could get to it? Scavengers might have been chewing on the body. You can see evidence of carnivore or rodent damage where the teeth marks are on the bone. You may see evidence of certain ritual behaviors for funerals. For example, did they burn or cremate the body? And then if it was buried, there might be signs of different types of weathering. Root etching means that plant matter has been growing over it. And then cut marks could indicate that someone butchered the body before they buried it. All right, and that wraps it up for chapter 15.